Hello, we're going to discuss how to find the equation of a line given the gradient and one of the points. A line passes through uh, several points, and how do you get the equation of a line given the gradient at one point? For example, find the equation of a line whose gradient is 4. For example, the gradient is 4, and one of the points that the line touches is 2, 5. So what do you do in such a situation? We know that the equation of a line is written in the form y is equal to mx plus c. Right? So what do you do? What you do is that you'll have an imaginary point, an imaginary second point. Right? Right? Say the gradient is 4. One of the points is 2, 5. So I'm saying you introduce an imaginary do not know, right? And the point, of course, any point contains x and y. And then you use the formula for getting the slope or the gradient of a line. And we say that the gradient of a line is the change in y over the change in x, all right? So you're going to simply say, the change in y is going to be now this y minus that, that's what we usually do, y minus 5 over change in x, which is apparently x minus 2. But again, now our gradient is 4. Okay, so we are going to simply say that y minus 5 over x minus 2, that is supposed to give us the gradient, but we already know the gradient is 4, right, which is 4 over 1. And of course, what comes next is simply cross multiplication. Okay, so what you're going to say now, it is 1 multiplied by y minus 5, and then it will be equal to 4 multiplied by x minus 2, right? So this is y minus 5 equals 4x minus 2. Open the bracket. So y is equal to 4x, and then we have negative 2. This one will change the sign to positive 5. So our equation is y is 4x and then plus 3. Okay, and from this equation you can really see that our gradient is coming there. The moment m is not the gradient, don't wait to be told you're wrong. And then we can see that this one is the y-intercept. Okay, and the y-intercept means that is where the line cuts the y-axis, and at the y-intercept x is 0. Sometimes they will tell you to find the gradient or maybe find the y-intercept. So you'll say that the y-intercept will be 0, 3, right? Because at the y-intercept x is always 0. Good. We are going to look at another uh, example that you might probably want to pause and try and solve it first before you mark later. Right, there's a little bit of a problem. Just hold on as I try and fix it. All right, so our next example, let's just call it B. And our next example is going to be, let's say our gradient is 0. And one of the points is negative 3, negative 5. So what we're going to do is the same thing we said. We are going to have an imaginary point, xy, and then we're going to say that the gradient is change in y over change in x. Apparently our gradient is 0. So it's going to be our change in y, that is y minus negative 5, y minus negative 5 over change in x, which is x minus negative 3, right? So 0 is going to be y plus 5 over x plus 3, right? So we're going to cross multiply so that we have y plus 5 is equal to 0 times x plus 3, so that y plus 5 is going to be equal to 0, and therefore y is going to be equal to 5. Right, the line y is going to be equal to 5. Looks like this, 1, 2, 3, 4, 5. Let's say our 5 is there. That is the line y is equal to 5, right? Any line that is uh, uh, parallel to the x-axis has its gradient as 0, right? A line that has no change in the x-axis has its gradient as 0. Why? Because anything you divide anything by 0, you're going to get 0. You're going to get math error. Right? You divide anything by 0, you're going to get math error. Okay, so let us look at another example whereby you're given the gradient and 1 point, the last one actually. So let's say you're given the gradient as negative 2, and then 7, 2 is the point. So we're going to do the same thing. We're going to have an imaginary point there, so that we have change in y, which is y minus 2, over change in x, which is x minus 7, being equal to the gradient, which is negative 2, because we know that the gradient is normally change in y over change in x. All right, so that we're going to have y minus 1 minus 2 being equal to 2 times x minus 7, so that y minus 2 is equal to 2x, and then that is negative 14. Therefore, y is 2x minus 14 plus 2, so that the equation of this line is going to be y is 2x, and then minus 12, right? So just a reminder, uh, uh, this one must be negative 2, this one must be negative 2, and because it is positive 2, then it means a mistake is done somewhere. A mistake was done somewhere. Yes, the mistake was done during the multiplication. This one is supposed to be multiplied by negative 2, right? So that when you open the bracket, you'll have negative 2, and also you'll have positive 14, because now negative times negative is going to give us positive, so that here you'll have negative 2x plus 14, and then this one is going to be minus 2, right? So that here we will have negative 2x, and then here we will have plus 12. So the true equation of the line is y is negative 2x plus 12. And I hope you've learned something from that, the moment you do not have exactly the gradient that you're given as your value of m, and that means even if the sign is wrong, you see we had 2 instead of negative 2, that should be a red flag that there is something that you have not done correct. So you go back and check. Okay, so in this case the negative 2 is our gradient, and this is the point where the line touches the y-axis. This is the y-intercept. I hope the video is useful and you have learned something.